Hello, welcome to my presentation on organ transplantation. This is Victoria Bergman from the University of South Dakota, doing my presentation for Speech 101. Why are human bodies so fragile? As with anything, constant use will cause parts to wear down and fall apart. Luckily, scientists have discovered ways to prolong both the life of the part in question as well as the person as a whole. However, there comes a point where the part cannot be salvaged anymore and must be replaced. Since this discovery, organ transplantation has grown safer and more comprehensible. The difficulty now stems from the growing disparity between the supply and demand. The world needs more transplantable organs. In this presentation, I will cover the disadvantages of the current organ, 3D printing that could lead to better organs, and organ growth that could easily be the future of transplant. First, one must know what the current disadvantages of organ transplantations are in order to understand why new techniques are in high demand. The first and most obvious is the lack of available organs. In 2012, 105,567 people were on the waiting list for new organs. Only 28,000 actually received their transplant. In order to be an organ donor, you must be diagnosed as brain dead yet still have functional organs. Even if you have live donors, there are still multiple risks. And there are severe advantages in regard to the quality of life of those who do receive transplants. According to scientists G. L. Dune and A. Humar, organs obtained from other humans are usually the best fit. However, there is a lack of supply, and, like all transplantations, it has the severe disadvantage that it requires long-term, indeed lifelong, immunosuppressants. Because the transplanted organs used to belong to someone else, the human body often perceives it as a foreign body that must be destroyed. In order to circumvent this effect, organ recipients are forced to take immunosuppressants that stop the destruction of their new organ. There are major risks to immunosuppressants, such as a higher susceptibility to infections and diseases and other non-anthropological effects. E. L. Dune and Humar also say that clinical xenotransplants have offered great hope for solving the problem of the expanding waiting list, but the primary hurdle is the formidable immunological barrier between species. Xenotransplants, or the transplantation of organs from one species to another, include risks such as the possible cross-species mutation of infections that could then go on to infect and possibly devastate the rest of the human population. Another problem may have with transplantation is the ethical debate regarding whether the widespread harvest of animals can be considered humane. Currently, transplantations from humans or animals are the only possibilities for complex organs such as kidneys or hearts. Both come with the problem of supply and the need for immunosuppression. Although there are others, these are the main disadvantages for the organs currently used in transplantation. New science techniques have begun to allow scientists to create original organs from the cells of the intended recipient, thus containing the possibility of eliminating both of these problems. Thomas Bolin from the University of Texas at El Paso is the co-founder of Cavito Biodevices, a company that uses 3D printing to create viable human tissue from the living cells of humans. Bolin claims one of the earliest passions on bioprinting, when his laboratory was having problems getting the cells to adhere to a slide in complex patterns. He was inspired to overhaul an inkjet printer, making it compatible for printing the cells directly onto a slide in whatever pattern was required. Cavito Biodevices CEO Laura Bosworth states that at this time, bioprinting can be used to create intricate network of cells and is even capable of making very small blood vessels. Currently, the company is in transactions with cosmetic surgeons to form artificial adipose tissue that can be used to create natural fat tissue for breast cancer survivors. 3D printing could lead to better organs because it uses living human cells that can create intricate tissues that are able to build off of a mold and be transplanted into a human with minimal use of immunosuppressants. While this technique is a major advancement, it requires an increasingly complex scaffold of some sort in order to achieve any sort of complex design. Science may have found the answer with the discovery of ghost organs. Doris Taylor, Director of Regenerative Medicine Research at the Texas Heart Institute at St. Luke's Episcopal Hospital in Houston, has found a possible solution that could narrow the demand gap. She has found that when a pig's heart is soaked in a special soap made from the same chemicals found in regular shampoo, the original animal cells wash away and leave a protein scaffold. This can be injected with the intended recipient's bone marrow stem cells and be placed inside a bioreactor, a box with artificial lungs and tubes that pump the oxygen and blood into it to keep the heart alive until it can mature. Preliminary tests done by the university show that these organs will be safer to the recipient because by removing the original cells, the risk of transmittable diseases is eliminated, and by injecting the recipient cells, the human body registers the new organ as a part of itself and thus does not attack it. This means that there only has to be a limited amount of immunosuppressants during the initial phases to ensure the underlying protein scaffold is not destroyed until the body naturally replaces it. Ghost organs, as this procedure is known as, are organs that have been stripped of their original cells and have had them replaced in order to make them match the recipient's body. Ghost organs could be the future of transplants. However, unfortunately, ghost organs have only been fully tested on mice, and like many scientific breakthroughs, are not yet available for human medicine. 20 people die each day waiting for a heart transplant that never appears. At this time, there are simply not enough organs available, and those that are available come with serious and often lifelong side effects. Scientific advancements such as 3D bioprinting and ghost organs hold the possibilities of bridging or collapsing the gap between supply and demand of transplantable organs. However, both are still in the developmental stage. It may take years before the first ghost organ is commercially available for human medicine. The world needs more transplantable organs, and science is finding a way. This is Victoria Bergman from the University of South Dakota about the future of organ transplantation.